Hello, my name is Ian Atkins with Green Zone Engineering, and in this video I'm going to demonstrate how to use our free online grow room cooling and dehumidification analysis tool. So what you're going to do is enter the inputs for a room that you are designing or troubleshooting in terms of it's not meeting the temperature and humidity set points that you would like it to, and you'd like to see what your options are. And then this tool is going to calculate the room loads in terms of sensible, that's heat load, and latent load, that's moisture load, at both the lights on and lights off conditions. It puts a table of the room loads here. And then the tool is also going to calculate the capacities in terms of cooling coil load, airflow, and reheat that are needed to remove the sensible and latent loads calculated and keep the room at equilibrium at the temperature, the room temperature and humidity set points entered in the inputs. I also do want to point out that the tool is psychrometrically based in the sense that it uses a psychrometric. That means the thermodynamic properties of air, like the grains of moisture per pound of dry air, to calculate how much airflows need to remove the latent load at the specific temperature and humidity set points entered. That allows the tool to analyze the achievable temperature and humidity set points. However, it also requires the user to have some understanding, some familiarity with thermodynamic terms and concepts in order to effectively use the tool. Now, going through actually using the tool, I am going to start by refreshing the page to zero out the results, and then I'm going to go through the inputs. So site elevation, this is used to calculate the thermodynamic or psychrometric properties of air since they depend on elevation. Canopy area along with transpiration rate per square foot of canopy are used to calculate total gallons per day of transpiration rate or moisture load in the room. The light quantity and the watts per light are used to calculate the heat load from the lights. The tool adds an additional 20% to the heat load from the lights to cover other minor heat loads like circulation fans, heat through the building envelope, LED drivers, anything else. The photo period is the number of lights on hours per day, typically 12 for a flower room. And then the lights on latent load percent is the amount of the total gallons per day of transpiration rate that the tool assumes go into the air during lights on versus lights off. The inputs that I have gone through so far are used for calculating the room sensible and latent loads. The next set of inputs are used for calculating how those loads are removed by the cooling and dehumidification system. So the tool asks for room temperature and humidity. That is the target temperature and humidity set points you are looking to achieve in the room, both lights on and lights off. The tool also asks for leaving cooling coil air temperatures, both lights on and lights off. The cooling coil leaving air temperature is something you can get in consultation with the manufacturers you are considering if you are designing a new project. If you are analyzing one of your current grow rooms, you may also talk to the manufacturers to see what you should be able to expect from your system. You may also get this value or validate this value through direct measurement or potentially through your building management system if that's a value available there. The difference between the room temperature and humidity and the leaving cooling coil temperature and humidity is what determines how much sensible and latent load is removed by the cooling coil for each CFM of airflow passing over it. So these parameters do have a major impact on the results. The last inputs are dehumidifier type and quantity. The dehumidifier types are the Anden model numbers, 210, 320, 710 pints per day. Quantity, how many dehumidifiers you expect to be in the room. If you are analyzing a fully integrated system, that is a system that uses reheat for dehumidification, an all-in-one package unit, or a 4-pipe chilled water, hot water air handler, that'd be an integrated system, enter 0. If you're analyzing a fully decoupled system, that is where the air conditioning system is cooling only, no reheat, enter enough dehumidifiers, or keep entering dehumidifiers until reheat equals 0 in the outputs. Or you can enter an intermediate amount of dehumidifiers, which would be an integrated system with reheat that also has some dehumidifiers to help supplement. I'm going to look at this first as an integrated system, so I'm going to enter 0 for dehumidifier quantity and then click calculate. So we have our results. The tool first displays the total lighting kilowatts and transpiration in gallons per day for quick checking. Then the room loads are displayed at 2 lights on conditions, both without plants and with plants, and then a lights off condition with plants. Notice that the 2 lights on conditions without dehumidifiers in the room are the same height, the same total load of 106.5 MBH. However, with plants, a large portion of that heat load is converted from sensible load to latent load as transpiration converts the heat into moisture in the room. Then the lights off condition has a positive latent load and a negative sensible load. This is because as water is transpired into the air, it also causes evaporative cooling that is equal and opposite to the latent load produced. The lights off condition does not consider any heat loads to the room other than from the dehumidifiers, if those are included, because I'm not worried about the heat loads in the lights off condition driving cooling system size. The cooling system size is going to be driven by lights on conditions. So using these loads, the tool then calculates the airflows needed based on the room temperature and humidity and leaving coil temperature to remove these loads. So for the full canopy lights on condition, we've got sensible load of 23.9 MBH and latent load of 82.5 MBH. The tool does is it uses the room condition 75-55 and the leaving cooling coil condition of 50 degrees and saturated to calculate how much airflow is needed to remove this sensible load, 894 CFM, and how much airflow is needed to remove this latent load, 6,979. And then it uses the larger of those 2 airflows to calculate the cooling coil load. So the cooling coil load is based on the enthalpy of the room conditions and the leaving cooling coil temperature, and it's the cooling coil capacity to bring 6,979 CFM from the room conditions down to the leaving cooling coil conditions. The reheat is then calculated based on the amount of overcooling, so it's the cooling coil load minus the heat load from the lights to the room. That's the reheat needed to maintain temperature equilibrium and not overcool the room. For the lights on, no canopy condition, this is kind of an extreme condition and sometimes could be omitted in calculations. I include it here because sometimes, especially in a decoupled system, this condition can drive the amount of airflow needed in the room. I put needed in quotes. Because this is, again, an extreme condition that isn't typically seen during regular operation in a grow room. So I kind of take the results here with a grain of salt. Already, this airflow that's calculated here is based on the room temperature added above plus 5 degrees. So based on, instead of 75 degrees I entered, it's based on 8 degrees entering, and again 50 degrees leaving, calculating the airflow needed to remove this sensible load. Then the lights off condition, similar airflows are calculated needed to remove these loads based on the room conditions and leaving cooling coil conditions. Sensible airflow here is negative because the sensible load is negative. That doesn't make a whole lot of sense. But again, the larger airflow, which is latent, is used to calculate the cooling coil load. One thing you will notice is that the reheat in this condition, 130 MBH, if you multiply 10.8 tons times 12 MBH per ton, you'll see that the cooling coil load is equal to reheat without dehumidifiers in the room, because all of the heat removed from the cooling coil without considering a heat load in the room needs to be replaced via reheat. So those are the results for a fully integrated system without dehumidifiers. Let's take note of the cooling coil load of 22.6 tons calculated and cooling coil load lights off of 10.8. I will point out that lights on cooling coil load of 22.6 is fairly high compared to the lighting kilowatt. That's certainly more than a half ton per kilowatt. It's nearing closer to a ton per kilowatt, which is quite a bit of capacity, and maybe too much capacity, depending on how much the equipment is able to turn down to match the load when the latent load is smaller during early flower and when the temperature and humidity set points are higher. So you could play with lowering the cooling coil leaving air temperature, and that would decrease this 22.6 tons. You should do that in consultation with an equipment manufacturer that you're looking at to make sure the assumptions you're inputting here are realistic. Another thing that you can look at is adding dehumidifiers. So I'm going to go ahead and add 2 dehumidifiers to this system and click calculate, see how that impacts the results. Wait a few seconds for the results to load. All right, so first things first, notice that the loads change. Now the first bar, lights on load with plants, is now taller than lights on without plants. That's due to the heat from the dehumidifiers. The lights off load no longer has a negative sensible load, and that is also due to the heat from the dehumidifiers. And then both the latent loads, lights on and lights off, have been reduced. The cooling coil load, lights on, went down from 22.6 tons to 16.1 tons. So that's reduced because the dehumidifiers, because the latent load is driving the cooling coil capacity to remove that moisture, and the dehumidifiers are reducing the amount of moisture that needs to be removed. Lights on and lights off, though, still both require reheat. So this does need to be, or this represents an integrated system, such as a package cooling dehumidification unit with reheat, or a 4-pipe chilled water, hot water air handler. It represents one of those system types, but also with dehumidifiers. So I think mixed systems with reheat and dehumidifiers are a good option to look at for a lot of grow rooms. Now I'm going to try adding 2 more dehumidifiers to calculate, or try to see if we can get reheat down to 0 to represent a truly decoupled system. So go ahead and click calculate, let this run again. We got reheat down to 0. We have, again, a lower cooling coil load now that this is basically just a heat load, and this represents a fully decoupled system. 50 degrees is maybe a little optimistic for a fully decoupled system. Let me also try changing that to 55 and clicking calculate again, see what happens. See if that's still enough, or see if we still have enough dehumidification to remove the loads without reheat. And unfortunately, we don't during lights on. We do during lights off, but not during lights on. So I'm not going to keep playing with this now. You could do this on your own, but basically what I'm seeing from this is with a 55 degree leaving air temperature, you actually need 5 dehumidifiers instead of 4 and again with a 55 degree leaving air temperature to fully remove your latent loads during lights on and lights off. Okay, so that is my demonstration to begin with of how to use our free online calculator. If you have questions on the tool, please put them in the comments below. I will be monitoring the comments and responding to questions. Want them there though, so so other people are able to make use of the answers. Please also feel free to reach out to us at Green Zone Engineering to help with your analysis, check your analysis, or further develop your analysis. Of course, this tool is somewhat limited in the analysis that it can do. We can further develop this analysis or, do full engineering design for your project if that's something that you need. Anyway, thanks for watching and hope this tool is useful for you.